G'day. This is the fifth of Jim Coroneos' integrals, of his famous 100 integrals that we're working through, and you can, if you've been watching the series, you can see that it's very similar to the fourth one. The fourth one had sin x cosine cubed x rather than sec cubed, and in a way that's a bit of a giveaway. When we see a product of two things like this, we could be looking at integration by parts, two functions, but it could be this is the derivative of what's here. Now it's certainly not the derivative of secant, but you may quickly pick up on the fact that sec x is 1 on cos x, and therein lies the solution. So let's have a look. Copy the sign. And since the secant of x is 1 over cos, I will do it in two steps because I'm not sure just how happy you are about doing it all in one. So this will be 1 over cos x cubed dx, which would be the integral of sin x times cos to negative 3x dx. So that smart little move, seeing that secant is a reciprocal of cosine, allows us now to look at this and see that we have a function to a power, and the derivative of the function is very similar to this. Now the derivative of cosine, of course, is negative sine, but as in the last video, or the last integral, we're looking at this pattern, that if we have some function to the nth power and we take its derivative using the chain rule, we get this result. First of all, treating it like x to the power n, we get n x to the n minus 1. That's the first step. And the second part of the chain is we multiply it by the function inside, and that means multiplying by f dash x. So we actually have three parts to this pattern. And if we can reproduce that here, then the integral is going to be exactly that. So let's have a look. We have a function to a power. The power we would like out the front is going to be 1 more than that. N is 1 greater than n minus 1. What is 1 more than negative 3? It's going to be negative 2. And to compensate for a negative 2, I'm going to put a negative half out the front. So that takes care of that. We've got that. What's the derivative of the function? What's the derivative of cosine of x? It's negative sine x. And to compensate for putting a negative there, I'm going to multiply by a negative 1 out the front as well. What does that give me? Well, out the front, it means I've got negative a half times negative 1 will be plus a half. And inside, I now have exactly the pattern of n, f dash x, f of x to the n minus 1 dx. And the integral of all of this will be that function, which will be cosine x to the negative 2 plus c. Now, we could write this doing this in reverse, that is, finding the reciprocal of cosine and just writing it as half 6 squared x plus c. So there you go. That would be a reasonable way of finding a way around that particular question. And really, that's as simple as you're going to get, I think. I hope you like the fact that it's set out without substitution. This little bit of work on the side often is a good memory jogger for the bits you want in place. I know that you can do this step differently by not writing this number here and instead writing it underneath on the next line, but I like to teach my students to integrate as the complete inverse function to differentiation, and I find that helps. So again, please click the like button and leave a comment. I'd love to see you as a subscriber, and thank you for watching.